Okay, so we're at the beginning of the booklet looking at conservation of momentum. Firstly, we need to decide what is momentum. And momentum is part of our laws of motion, in that because it's from Newton's first law that an object will tend to keep doing what it's already doing. And so if an object is stationary, then it's going to stay stationary unless it's acted on by an unbalanced force. And an object that's moving will keep moving. And the same thing, unless it's acted upon by an unbalanced force. But this tendency to keep moving is called momentum. And we can also think about how much momentum does an object have. It's easy to think about how easy is it to stop that object. So if we've got a truck going at 100 kilometres an hour down the Bass Highway, how hard is that going to be to stop? Pretty hard. So it's got a lot of momentum. And momentum then, we can see, is made up of a combination of mass and velocity. So to have a bullet, say, with the same momentum as that truck, it needs to be travelling at a very, very high velocity because its mass is so much smaller.
The surface area when the bullets go through the truck.
Well, we're not shooting them at each other in this context. I'm just comparing the amount of momentum that they have. So if I would, okay, let's think about a car and a truck. In that, and we're not running them into each other still. That because the car has a lot lower mass, it needs to travel a much higher velocity to have the same momentum as the truck. And we can also think that it's going to be a lot easier to stop the car than it is to stop the truck. Alright, so we have this formula. It's on your formula sheets. It's written as P, but it should be rho, the Greek letter rho. I'm not quite sure why it's incorrect. But I want you to note that it's made up of multiplying mass times velocity. And its units are just that, kilograms meters per second. A lot of times when we've formulated a new quantity, if you like, by combining other things together, we've given it a new unit, but we haven't in this case. It stays the same. It's a vector quantity. It has direction. Okay, so not only does it have this magnitude, in kilograms meters per second, it also has direction. All right, so we can start out with our worked example, where we have a car with a mass of 1,400 kilograms, and it's moving at 60 kilometers an hour. North. And just like all of our other equations that we've had before, we need to use our SI units in our equations, and so we need to convert this kilometres an hour to metres a second. Do I multiply or divide by 3.6? Divide by 3.6. So that is going to give me 16.67, it's actually 6 repeater, metres a second. And we also are just keeping in the back of our minds that it's north. So our momentum then will just equal the 1,400 times the 16.6 repeater, which gives us 23340. And if we look back at the question, it started out with 3 sig figs. So we're going to change this to 3 sig figs. We could write it as that. towards north, because we have to have direction. Or we could write it using scientific notation. Okay. Now you've got a couple of questions in set one, which is tiny wings. So I'll let you have a go at answering those questions on page 7.